This spacesuit, built in 1974, was reported to cost between $15 million and $22 million. Today, that would be about $150 million. Having not delivered any new mission-ready extravehicular suits since then, NASA is running out of spacesuits. In fact, NASA are down to just 4 flight-ready EVA suits. Since 2009, NASA has invested more than $200 million in spacesuit development, recently unveiling the Zemu prototype. But NASA still does not have a new fleet of spacesuits. So why has it taken so long for new spacesuits to be built? And what makes them so expensive? Spacesuits are so expensive because the complex, human-shaped spacecraft. Think about them in terms of spacecraft, not as work clothes. A spacesuit has to protect an astronaut from the vacuum of space, from radiation coming from the sun and other bodies, and it has to protect against fast-traveling particles that are traveling up to 18,000 miles an hour that could penetrate the suit. They provide oxygen, communications, telemetry, and everything else that a human needs to survive, all rolled into one tiny, human-formed spacecraft. But the spacesuits NASA currently uses are more than 40 years old. 18 suits were developed for the Space Shuttle program in 1974 and have vastly overworked their original 15-year life design. Suit No. 1 was only used for certification, while Suit 2 was destroyed during ground testing. 2 suits were lost in the Challenger disaster in 1986, and another 2 in the Columbia disaster in 2003. The most recent spacesuit loss was Unit 17, during SpaceX 7's cargo mission mishap. The exact cost to replace this unit is unknown, but estimates range as high as $250 million. For the remaining 11 suits, the damage is mounting, with 7 in various stages of refurbishment and maintenance. That leaves only 4 flight-ready spacesuits aboard the International Space Station. In fact, NASA's first all-female spacewalk was postponed because the space station had only one medium-sized suit. This milestone was finally achieved when NASA sent up a medium torso shell to fit the existing larger suit. NASA has invested about $250 million developing the Zemu suit for its Artemis program, which plans to take humans back to the surface of the Moon by 2024, with a view to eventually go to Mars. With that goal fast approaching and the number of existing spacesuits dwindling, NASA engineers face a new kind of space race. There is absolutely a sense of urgency, not only because of the number of suits itself is relatively small, but the individual components that we use to keep the suits healthy and moving forward is also dwindling. A great example of that is the carbon dioxide sensors. The design that the current suits fly is a heritage design, some of the components of which are no longer produced. Some of the vendors that made those components no longer even exist. And so today the CO2 sensor is a great example of a component where a replacement design that will work for both the existing suit and the new suit basically would be a drop-in replacement that's compatible with both suit designs. The gloves are an amazing and intricate component, but at the end of the day, the pressure garment, including the gloves, is actually less expensive than the life support system. The backpack that is worn on the back of the suit is a highly compressed set of technologies that do everything from maintain temperature to remove carbon dioxide and continue to provide pressure inside the suit itself. And I think, in the end, several of those components are each more expensive than most of the other garment components, like the gloves. In total, almost 1.5 liters of water leaked into his helmet, threatening to drown Parmitano mid-spacewalk. But considering that NASA's Apollo-era spacesuits allowed 12 humans to walk on the Moon 50 years ago, and considering the Space Shuttle-era suits have been used on over 200 spacewalks, is such a large investment in new spacesuits needed? Well, that depends on what you're going to ask the astronauts to do. Walking on Mars is different from walking on the Moon. It's a different environment, it has different hazards. So when you're picking these assignments for astronauts, you have to take into account, do you want the astronaut to be able to walk, bend over, pick up things, or will he or she be carrying something? So you have all those considerations that have to fold into that design. We believe it is a necessity. Some of the components and some of the design concepts are no longer consistent with our values and expectations in terms of the quantity and distribution of crew members that we fit. I believe that, yes, the investment is appropriate and worthwhile. All those dollars get spent here on the ground, and they are returned to us in ways that ultimately yield benefits for all of humanity and for the taxpayers here in this country. We are also lowering the barriers to entry from a commercial perspective. Getting more companies involved, getting more companies competing and innovating to try to continue to reduce that price. In an effort to develop technology at lower costs, NASA often sets design challenges for innovation, sometimes partnering with the designers and companies who impress the most. In the 2009 Astronaut Glove Challenge, Ted Southern bagged the second-place prize of $100,000. He and his partner, Nikolai Moiseev, a leading Russian spacesuit engineer, used their winnings to form Final Frontier Design. If we were to take the design of the suit we have today, if we were to reproduce copies of that suit, we believe that would cost us in the range of $15 million to $25 million per unit. But we do believe that the design that we're developing today with the Zemu should not only stay within that range, we actually believe that competition and the innovation that we fostered will actually drive that cost lower per unit. How does NASA's spacesuit costs compare with other countries? Russia's equivalent of the EMU suit is called the Orlan. Like NASA, it also has 4 suits aboard the space station. But it also has reserves, both at the Cosmonaut Training Center in Star City, Russia, and at Johnson Space Center in Houston, Texas. According to Nikolai Moiseev, who is one of the few engineers to work on both America's EMU and Russia's Orlan, unlike NASA, Roscosmos has continually developed new generations of spacesuits.